This video is actually a costing exercise. It is important to know the cost of your product in order to determine the appropriate selling price for it. You will also need to know how to position your dried product versus comparable fresh products. This is really a consumer education issue in a number of areas. First, we have to look at cost, then usage amounts. You also have to educate the consumer in the advantages of dried products versus their fresh counterparts. You also may have to get over some of the disadvantages of dried products versus fresh products. You need to put a proper spin on your product in order to entice consumers into purchasing it. The most common problem with selling dried products is the consumer perception that the cost is excessive. One argument is, why should I pay $5 for 250 grams of your dried product when I can buy 2 kilograms of fresh product for the same price? Let's consider a fresh product with 85% moisture and compare it to the same product in its dried form with only 10% moisture. So we have to ask ourselves, what is the equivalent amount of fresh material that corresponds to 250 grams, i.e. a quarter of a kilogram, of the dried material? 250 grams of dried product at 10% moisture will contain 90% solids. The weight of the solids then will be 225 grams. The remaining 25 grams will be water. So how much fresh material contains 225 grams of solids? Restating the question, we could ask how much fresh material contains 225 grams of solids. So let's let X be the weight of the fresh material in grams. At 85% moisture, the solids content is 15% by weight. This means that 15% of X grams is the weight of solids in the fresh material, which we know was equal to 225 grams. We also know that the solids at the start of the drying process will equal the solids at the end of the process unless there are some unexpected losses. We can say mathematically that 15% of X, which we write as 0.15x, is equal to 225 grams. This allows us to solve for X by dividing 225 grams by 0.15, and we get 1,500 grams, which is actually equal to 1.5 kilograms. Therefore, 250 grams of dried product is equivalent to 1,500 grams or 1.5 kilograms of fresh material. This means that you need only about 1/6 as much dried material as you do fresh material. Ignoring production cost, the dried material would reasonably be 6 times the price of the fresh material or the wet material on a weight basis. However, this is definitely not the case. There are significant production costs involved in drying a product. You may have to sell your dried product for 10 times the price of the equivalent weight of fresh product to recover your costs. We'll look at some of the costs later. Let's consider fresh tomatoes with 95% moisture and compare them to the same product in its dried form with only 10% moisture. What is the equivalent amount of fresh tomatoes that correspond to 250 grams of dried tomatoes? 250 grams of dried tomatoes at 10% moisture contain 90% solids. The weight of solids will be 225 grams. What weight of fresh tomatoes contain 225 grams of solids? So we'll restate the question at the top of this slide so you can follow through with the calculations, and we're going to let X be the weight of fresh tomatoes in grams. At 95% moisture, the solids content is only 5% by weight. This means that 5% of X grams is the weight of solids which we know is 225 grams. So we can then say that 5% of x, which we write as 0.05x, is equal to 225 grams. Solving for x, we get a value of 4,500 grams, or 4.5 kilograms. Therefore, 250 grams of dried tomatoes is equivalent to 4,500 grams, or 4.5 kilograms, of fresh tomatoes. This means that you need to use only 1/18 as much dried tomatoes as you do fresh tomatoes. And of course, this depends on the end use. There are applications where dried material will not be appropriate for use in place of fresh material. Dried tomatoes can be used in stews, but are not suitable for use in most salads. So we have to look at rehydration then. Usage amounts are a key point and may require recipe modification to compensate for the water required to rehydrate the dried material. Rehydration is the process of adding or putting moisture back into previously dried materials. Generally, it is not possible to rehydrate materials to their original water content. So we're going to do some examples which you will see on the next slides. So let's take a look at the rehydration of carrots. Originally, the carrots contain 89% water on a weight basis. In the drying process, we are going to remove much of this water, and what we end up with is dried carrot slices containing only 5% water in this case. Then we will go through the rehydration process where we add hot water and we end up getting a rehydrated product with 76% water. And as you can see, we did not get back to the original moisture content of these carrots. In the next example, we're going to look at some tomatoes. Here we have some tomato wedges which contain 93.8% water on a weight basis. Again, we will go through the drying process where we remove water. This gives us dried tomato wedges containing 5% moisture in this case. Once again, we will go through the rehydration process where we use hot water and we end up getting hydrated tomato wedges with 80.3% water, which is not nearly as much water as the tomatoes had originally. But in a stew, this is quite acceptable. So in order to modify existing recipes to accommodate dried materials, you may need to do some experimentation to determine the amount of water to add. In some cases, you may recommend rehydrating the material before incorporating it into a stew, etc. This may simplify things greatly. You can do calculations of how much water to add with a given amount of dried material. However, most recipes are based on volumes, so you will need to do some work to find the proper volumes of dried material and water. Hot water tends to rehydrate better than cold, so be mindful of this in your recipe recommendations. Now let's get into the costing exercise itself. In order to determine the selling price of your product, it is necessary to have a realistic evaluation of the costs associated with producing it. There are factors involved that are often overlooked or dismissed as being trivial. No cost should ever be considered as being trivial. Capital costs include the cost of equipment, which you will amortize over time or over a number of batches of product. If something cost you $100, you may decide to amortize it or spread the cost of it over 100 batches of product and simply tack on $1 of cost to each batch to cover the cost of the original equipment that you purchased. We also have raw materials and ingredients, and these are the costs of fresh produce plus any other associated cost per batch of drying that you do. We also have utility costs. Electricity is often forgotten, but it is a very important cost factor and should be on everyone's list. We have water, And we also have disposal cost if you make some off-spec product, or if you have product that hasn't been sold and you need to get rid of it. Labor costs. This is the cost of your time and any of the staff members that you employ. Always remember to pay yourself. Your time is money, so include the cost of your labor when you're doing a costing exercise. Don't forget packaging costs, the primary packaging that the product goes in. Perhaps you're using plastic bags or glass jars with lids or plastic bottles. They all have to be factored in. You also need to remember labels and stuff like that, as well as secondary packaging when you may put these bottles or jars or plastic bags into cardboard boxes that you leave at your point of sale. Even Ziploc plastic bags cost money, so don't forget them. Transportation and storage costs are important as well. Don't forget the cost of transporting your product to market. An easy way to calculate the electricity cost for drying is to monitor the number of hours your dryer is running. Multiply the operating time by the wattage of your dryer in kilowatts. Then multiply this by the cost per kilowatt hour. It may take 10 hours to dry a batch of mangoes, and your dryer may be running for a bit longer than this, for example, 11 hours. Many home dehydrators have a 500 watt rating. 500 watts is equivalent to half or 0.5 kilowatts. We're going to assume that the cost of electricity is 68 cents or 0.68 Caribbean dollars per kilowatt hour. So the electricity cost per batch will then be 11 hours per batch times 0.5 kilowatts times 68 cents per kilowatt hour. And this then tells us that it will cost us $3.74 in East Caribbean currency per batch for the electricity. Please don't get too upset if my exact cost for electricity per kilowatt hour is not entirely correct. You can simply substitute the proper value in here when you do your own calculations. You then add up all the cost per batch of the dried material. You can find the cost on a weight basis by dividing the cost by the weight of the dried product. And don't forget to apply a profit or a margin to your costs so that you can make some money for all your work. Here's a final thought. You are not going through all of the work of preparing a dried product to lose money. Therefore, you must be prepared to charge a fair price for your product that covers all your costs and gives you some profit. Thank you very much.